Lesson: Edge computing and blockchain compliance considerations. Edge computing and blockchain technology are significantly reshaping the landscape of governance and compliance. The convergence of these technologies offers transformative potential, but also introduces complex compliance considerations. The actionable insights and frameworks discussed here provide a foundational understanding for professionals seeking to navigate these challenges effectively. Edge computing refers to the decentralized processing of data closer to the source of generation, such as IoT devices, rather than relying on centralized cloud data centers. This approach reduces latency, enhances real-time data processing, and improves bandwidth efficiency. In contrast, blockchain is a distributed ledger technology that ensures data integrity, transparency, and immutability. When these two technologies intersect, they present unique opportunities and challenges for compliance, particularly in ensuring data privacy, security, and regulatory adherence. A primary compliance consideration in the integration of edge computing and blockchain involves data privacy and protection. Given the decentralized nature of edge computing, data is often processed outside the traditional centralized IT infrastructure, increasing the risk of data breaches. Blockchain technology, with its immutable ledger, complicates data deletion and modification, posing challenges to compliance with laws like the General Data Protection Regulation. To address these issues, organizations can implement privacy-enhancing technologies such as homomorphic encryption and zero-knowledge proofs, which allow data to be processed without exposing it. These tools can be integrated into edge computing frameworks to ensure that data processed at the edge complies with privacy regulations. Moreover, the deployment of blockchain at the edge necessitates robust identity and access management systems to prevent unauthorized access and ensure data integrity. IAM solutions, such as decentralized identifiers and verifiable credentials, can be employed to authenticate devices and users in a blockchain network. These systems facilitate secure and compliant interactions between edge devices and blockchain platforms by maintaining a verifiable chain of trust. Compliance with data sovereignty laws is another critical consideration. Data sovereignty refers to the concept that data is subject to the laws of the country in which it is collected. Edge computing enables data to be processed locally, which can help organizations comply with data sovereignty requirements by keeping data within geographical boundaries. However, integrating blockchain, which inherently involves data replication across multiple nodes, can complicate compliance. To mitigate this, organizations can use permissioned blockchain networks where data replication is restricted to nodes within a specific jurisdiction, thus aligning with data sovereignty laws. The scalability of edge computing and blockchain systems also poses compliance challenges related to system performance and reliability. As the number of connected devices increases, ensuring that edge and blockchain systems can scale while maintaining compliance with industry standards and regulations is crucial. Organizations can adopt microservices architecture for edge applications, which allows for independent scaling of services and facilitates compliance by enabling targeted updates and audits. Blockchain scalability can be enhanced through Layer 2 solutions, such as state channels and sidechains, which offload transactions from the main chain, ensuring that compliance requirements for transaction throughput and latency are met. To ensure effective governance and compliance, organizations must adopt a holistic risk management approach that encompasses both edge computing and blockchain technologies. Risk assessment frameworks, such as the NIST cybersecurity framework, can be tailored to address the specific risks associated with these technologies. This involves identifying potential threats, assessing vulnerabilities, and implementing controls to mitigate risks. Regular audits and compliance checks should be integrated into the risk management process to ensure ongoing adherence to regulatory requirements. The convergence of edge computing and blockchain also necessitates a reevaluation of existing data governance policies. Organizations must establish clear data ownership and accountability frameworks to address the complexities introduced by decentralized data processing and storage. Data governance frameworks like the DAMA-DM BOK provide comprehensive guidelines for establishing data stewardship, quality, and lifecycle management practices. Implementing such frameworks ensures that data governance policies are aligned with compliance objectives and industry best practices. Case studies demonstrate the successful implementation of these strategies. For instance, a healthcare provider leveraging edge computing and blockchain for patient data management implemented PETs to comply with HIPAA regulations while ensuring data security. By adopting a permissioned blockchain network restricted to nodes within a specific jurisdiction, they addressed data sovereignty concerns and maintained patient privacy. This case highlights the importance of integrating compliance considerations into the design and deployment of edge computing and blockchain solutions. Statistics further illustrate the impact of these technologies on compliance. According to a report by Gartner, by 2025, 75% of enterprise-generated data will be created and processed at the edge. This shift underscores the need for organizations to address compliance challenges associated with decentralized data processing. Additionally, a survey by Deloitte found that 55% of organizations consider regulatory compliance a significant barrier to blockchain adoption. These figures emphasize the importance of addressing compliance considerations in the integration of edge computing and blockchain. In conclusion, the intersection of edge computing and blockchain presents both opportunities and challenges for governance and compliance. By leveraging privacy-enhancing technologies, robust identity and access management systems, and compliance-focused frameworks, organizations can address the complexities of data privacy, security, and sovereignty. Implementing scalable architectures and adopting comprehensive risk management and data governance practices further ensures compliance with regulatory requirements. Through case studies and statistical insights, it is evident that proactive integration of compliance considerations into the deployment of these technologies is crucial for organizations seeking to harness their full potential while adhering to governance and compliance standards.